Hello all, today we are covering rotations. You guys will be able to draw these in the coordinate plane or without the coordinate plane. So our first two new vocab terms are center of rotation and angle of rotation. So our key concept here is rotation. Now this is going to sound kind of difficult until I explain it, so just listen along. A rotation about a fixed point called the center of rotation through an angle of x degrees is a function that maps a point to its image such that, okay? If the point is the center of rotation, the image and the pre-image are the same point. So if you have your center of rotation, the point is the same thing, nothing changes. A and A prime in this case would be the same thing, okay? If the point is not the center of rotation, then the image and pre-image are the same distance from the center of rotation, and the measure of the angle of rotation formed by the pre-image, center of rotation, and image x, or points, is x degrees, okay? So basically, look over at the diagram. From the center of rotation to the pre-image is congruent from the center of rotation to the image. These are the same length away. And then the angle of rotation is formed by the connection of the image, the center of rotation, and the pre-image, in this case 120 degrees. That is all that is saying. So for this diagram, which description best identifies the rotation of triangle ABC around point Q? The best way I think to do this is to draw an angle between A, the center of rotation Q, and A prime. This gives us an idea of what the angle should look like. It is either one of two of our 90 degrees. We know we go from the normal ABC over to the prime version. So if you look there, this way around is counterclockwise. If you look at a clock, you can tell. And this way around is clockwise. Okay, so this is 90 degrees counterclockwise. All right, now we come to our key concept. How can we use this on a coordinate? So 90 degrees, to rotate a point 90 degrees counterclockwise, then the origin, you multiply the y-coordinate by -1 and then interchange them. So basically here is a symbols version, and the y is multiplied by -1. And they are then interchanged. For a 180, you just multiply both the x and y by -1. And for a 270 counterclockwise, you multiply the x coordinate by -1 and then interchange them. So, if you think about this, a 90-degree counterclockwise is the same as going 270 degrees clockwise. 180 is a little simpler. It's the same either way. And 270 counterclockwise is similar to the first one. We have 90 degrees clockwise. Does the same thing. So if you were asked for a clockwise version, you just pair it up with one of your counterclockwise. Okay, so triangle DEF has vertices of 1, 1, 4, 5, and 5, 1. We need to rotate this 90 degrees counterclockwise about the origin. Notice what we had above is only for the origin. Those sort of mapping equation type things. So, D is 1, 1. E is 4, 5. And F is 5, 1. If you scroll back up, if you have a 90 degrees counterclockwise, you want to multiply the y-coordinate by -1 and then flip the coordinates. So I end up getting -1, 1, for D prime, make sure to label it, I get negative 5, 4, and then I get negative 1, 5. So if I plot these D prime, E prime, and F prime, it'll look like this. Okay, and then if you would like, you can take a quick check by drawing an angle between, say, D prime, the center of rotation, and D. Make sure that is 90 degrees counterclockwise. And it sure is, so we're good to go there. We can move on. We have another 90-degree counterclockwise one, so you just follow along. It should go pretty fast. There is my ABC triangle. And I do the same thing as I did before. I'd make my Y, my original Y, the opposite sign, and then switch X and Y. And now since it's 90 degrees counterclockwise, it should be in this quadrant, so we'll make sure it is when we graph. Make sure to continue to label your points, just like that. And there we go. We have 2 more examples. This time we have a 180-degree counterclockwise. JKL has vertices. J is 3, negative 7. K is 1, negative 1. And L is 5, negative 3. We'll go ahead and connect the dots. And since we're rotating about the origin 180 degrees counterclockwise, we know it should be in this quadrant. And these are possibly the easiest. I'm actually just going to write J prime, K prime, and L prime because the X and Y's don't switch, only their signs change. So if it was positive, it becomes negative, and if it was negative, it becomes positive. And then you can graph it. And there you have it. We have one more. This is a 270 counterclockwise. So we have PQR. P is 26. Q is 5,2. And R is 7,5. Draw in your lines. And then from here, we go ahead and just, I'm going to go ahead and rewrite these. And then we'll figure out what our image points are. This time we multiply X by negative 1 and then flip them. We know it should be in this quadrant right here. So we'll make sure it actually is in that quadrant by graphing it over 6 down 2. It's P prime, Q prime is over 2 down 5. And R prime is over 5 down 7. It is indeed in the right quadrant, and we have our completed graph. All right, have a good evening.